Hi, this is Giselle. Lesson 2.1, multiplying integers.
After this lesson and our working class, I will be able to multiply rational numbers, apply properties of operations as strategies to multiply rational numbers. So basically what it's saying is that I can apply different properties to multiply those rational numbers. All right, so to start off, we're going to work on multiplying integers using a number line. So when we use a number line, it's a little bit different than when we use a number line for adding and subtracting. So we're going to work with Henry, who made 3 withdrawals of $2 each from his savings account. And we want to know what was the change in balance. So in this case, I know that multiplication-wise, this would be 3 times a negative 2 because it's withdrawals of $2. So to graph this, we would start at negative 2. Okay, so you have 0, and then you would go to negative 2. So after the first withdraw, he lost $2. Okay, so moving 2 units to the left. But then, since 3 times 2 means negative 2 plus negative 2 plus negative 2, I have to do that 3 times. So now I've moved once. I move a third time. So after the second withdrawal, he has lost $4. And then a third time tells me that 3 times a negative 2 would be negative 6. So after moving 2 units to the left 3 times, I got to a negative 6. So the change in Henry's balance was negative $6. So as a number, it's negative 6. If I put it into words, it's a loss of $6. Not a loss of negative 6, just a loss of 6. Okay, so now we have Lisa, who plays a video game, and she loses points. She loses 3 points, so loses 3 points 2 times. So in this case, twice she has lost negative 3 points. So if I change this to addition, I know that this means negative 3 plus a negative 3. So based on my rules of addition, I just add these two numbers and keep the sign. So I know my answer should be a negative 6. However, we're going to multiply. So when I do this on the number line, again, I start at 0. Okay, and then I show that she loses 3 points. So that's the 1, and then I show that she lost 3 more. So that would be the 2 times negative 3, and that got me an answer of negative 6. All right, so when you're using the number line, always look at your multiplication in terms of repeated addition, and your number line will be a little bit easier to put together. So what do you notice about the product of 2 integers with different signs? So if you go back and look here, we have a positive and then we have a negative. And we have a positive and we have a negative. Now here's the thing. When I have my repeated addition, my signs are the same, so it stays as my negative number. Whenever my signs are different, you should notice that no matter what, the answer was negative. Okay, so I can type on here, when the signs are different, the answer was negative. Now we're going to take a look at this in terms of using counters. Now we're looking at an actual negative, negative times a negative. First, we're going to model negative 3 times negative 4. We're going to look at it as 3 groups of negative 4. So if I have 3 groups of negative 4, I would have these 3 groups with negative 4 pieces each, because remember the reds are negative. Okay, and then I know that this would give me negative 12. Okay, here I'm going to do 3 times, but I'm going to do a positive 4. Again, I still get 12. Okay, but what you have to remember is we talked about how this negative sign actually means opposite. So let's look at it this way. I want the opposite of 3 times a negative 4. Okay, so no matter what, 3 times 4 gives us 12. That's basically what this here is trying to show you, that no matter what, three times 4 is still going to give us 12. So the number, the product doesn't change. But in this case, I know that 3 times a negative 4 would give me negative 12. But then I want the opposite of that. Okay, because I have this negative out here, so I want the opposite of 3 times the negative 4. So the opposite of that negative 12 is going to be a positive 12. So I know then that negative 3 and negative 4 gives me a positive 12. Again, look at that first negative sign as telling you I want the opposite of the result. All right, now I'm actually going to give you a little example here. I'm going to open up a new page. So let's just do negative 7 times negative 2. Ignore the signs. Do 7 times 2, or ignore your first sign. Do 7 times the negative 2. And again, this is 7 groups of negative 2. So I know that that's a negative 14. But then I want the opposite of that answer, which would be a positive 14. So basically what we're saying is, looking at this first number, always multiply it like it's a positive, and then if it's actually a negative, that means you need the opposite of whatever your product was. Moving right along. So what do you notice about the sign of the product of 2 negative integers? So what you should have noticed here is that when we have 2 negatives multiplied together, give a positive product. Okay, again, because you're ignoring that first negative sign until the very end. Okay, what can you conclude about the sign of the product of 2 integers with the same sign? So now we have to go back to when we multiplied just with positives. Well, our answer was always positive. Okay, and think about it this way. If I have 4 times 4, we know that that gave us 16. Now, if I want to do negative 4 times negative 4, 4 times 4 gives me the 16. Because it's a negative 16. But now I want the opposite of that, which is a positive 16. All right, I'm going to rewrite it one more way to try and help us out here. So if I have a negative 4 times a negative 4, ignore the sign and do 4 times negative 4, which gives me negative 16. And then I want the opposite of whatever that answer was. So the opposite of negative 16 is positive 16. Right, Giselle?
Yep.
Okay, so what can you conclude here? What you should conclude then is that when the signs are the same, the answer is always positive. So again, this is different from our addition rules, because when we have a negative plus a negative, it gives us a negative. But a negative times a negative is actually going to give us a positive. So we have to make sure that we're going slow and practicing these rules. Okay, the nice part about this, though, is that the multiplication stays exactly the same. So it's not like the addition where all of a sudden we're using subtraction to solve. You just multiply like usual. So here I'm just going to give you an example. We're going to just ignore this negative sign for a minute and do 3 times 5. We know that's 15. Since I only have one negative, that means my answer is going to stay negative, because I don't want the opposite of the opposite. Okay, so but here I have negative 10 times negative 2. So I need the 10 times negative 2 gives me the negative 20. But then I want the opposite of that, which is actually 20. So again, negative times a negative is always a positive. Negative times a positive is always a negative. So think of it this way. We said the opposite of the opposite is always the number itself. It's always going to be, so here the opposite of the opposite is always going to be a positive. But here we just want the opposite once. So when you just want the opposite once, we know 7 times 6 would be 42, and I need the opposite of that. So here I have 15 times 3. It gives me 45. The negative 3 tells me I would need the opposite, but then that second opposite sign means I want the opposite of the opposite, which is positive. All right, and then 8 times 4 is 32. And 0 times negative 22. Now, no matter what, anything times 0 is
0.
Very good, Giselle. All right, so you guys have these problems that I want you to finish for class next time. As always, if you have any questions, please be sure to write them down or email me so we can go over them in class.